Okay, he was wondering if adult stem cells are so great, why is there such a controversy between embryonic stem cells and adult stem cells? And it comes down to money. Geron Corporation, hi guys, owns all the patents for embryonic stem cells, all the use patents. So anytime anybody uses embryonic stem cells for treatment, they get a royalty. They get the cut of the pond, okay? Back when Jamie Thompson and Thomas Gerhardt, they were funded by Geron Corporation, by the way, published their results, a few months later, there was a letter sent to, I think, whomever it was, Reagan or whatever, one of the conservatives, saying we ought to do embryonic stem cell research, and it was signed by 40 Nobel laureates. But being the person that I was, I looked up the names on the internet, and none of those Nobel laureates were in science. And I called one up and I asked, and he said, well, Geron Corporation paid me to sign the letter.
Wow.
Okay? It's money. Now, the other thing is, I work at Mercy University in Macon, which is a teaching medical school, okay? I don't look at Harvard. I don't look at Stanford. I don't look at whatever. They're pushing embryonic stem cells because they can repair anything. Guess what, guys? Adult stem cells can do the same thing. 2 years ago, I took 13 people with me to Snowbird, Utah. It's an international meeting on stem cell. We blew the doors off because it was an embryonic stem cell meeting. First day I was, Macon, that's in the state of Atlanta, right? No. Got this confused. You have Georgia. Atlanta's in the upper left-hand corner. If you put took an arrow or a dart, middle of the state, that's Macon, Georgia. That was the first day. And they didn't believe our results. Second day, they knew at least where Macon was, and they knew Atlanta and Georgia were not the same thing as far as state and city witness. By the third day, they were kind of, but by the sixth day, they were saying, can we collaborate with you? This sort of thing. And basically, when we were in Vancouver last year, basically the same thing. We went to an embryonic stem cell meeting, and I took 12 people with me, and we all presented on adult stem cells, and we blew them out of the water. It's so ingrained that the only thing that you have in your body are progenitor cells. And you talk to an embryonic stem cell person, and they'll say, you have progenitor cells in your body that will decrease with age, they're not plastic, and you're going to croak. Embryonic stem cells are plastic. We can make any cell in the body, no problem. They fail to mention mesodermal stem cells. Well, mesodermal germinal lineage stem cells are now starting to become, more and more people are working on those. We worked on those 15 years ago. We're now working with the pluripotents and the totipotents. My lab is the only one in the world with the totipotent stem cells, and I'm only one of 3 labs in the world with pluripotent stem cells. So we're trying to publish, trying to get our stuff out there. It's just going to be a matter of time, and this way back. Yes?
How does the Obama, the reversal of the embryonic stem cell research policy affect or influence your research?
Well, all the money is going to be going to the embryonic stem cell researchers, okay? Now, I'm hoping some of that will trickle down to us. He's got $8 billion stimulus package to NIH. They're called the NIH Challenge Grants. They're due April 27th. We are submitting about 20 grants for that program across the board. Parkinson's, COPD, multiple sclerosis, muscular dystrophy, diabetes, anything we can think of, we're submitting. Hopefully 1 or 2 will hit, and then we can move forward. And as soon as we start publishing in humans, embryonic stem cell people barely can get it to work in animals. And we're doing it right now. I'm going with the IRB. To do it in humans, you have to go through a series of experiments to prove that it's not harmful for humans. You have to do large animal studies before you can do the human studies. My large animal is a horse. So our first studies were done in horses. We had 6 of them. We got the blood from those. We're going to count the cells. Then the next study has to be done on normal humans to make sure that we can have an increase in stem cells. We found all of our previous experiments, we extracted the cells and put them back in. We have now found the compound where we don't have to do that. We just give a pill, it mobilizes the stem cells out to periphery, they circulate in the blood and fix the problem, which is even better. But we have to prove that it's not harmful to humans. So, I'm done the first set in horses. Our second set, it's placebo versus experimentals, go into humans in about a month. And the law school has graciously obliged to help me with it. We're taking ages from 21 to 85, and all I need are 36 people, and your secretaries have already volunteered. He looked at the study, so putting your note or not. And since my lab is over at the law school anyway, we can keep everybody out of a closed situation. Then we can go to treat people. Now I have a collaborator that's already a peeper, and that's the one with the Parkinson, and he's the COPD, and he's taking everything under the sun. And we're getting preliminary results from that, and everybody he's treated with this compound, they're getting better. We haven't had we've had some setbacks. To one other person, COPD people, was at 60% O2 sat in the blood. Okay, he went up, he took the compound, got up to 90%, felt so good, loved to play golf. He did 3 rounds, 18 rounds of golf back to back. Got worse. No, didn't give me a break here. We had another person an epileptic that was on the medication. Since he's been on the medication, he hasn't had an epileptic fit for a seizure, and he was averaging 2 to 3 a day, so it was starting to wean him off his epileptic medicine, but he also had a rotator cuff injury. It felt real good. He did 40 push-ups. Dumb. What can I say? Unfortunately, the researcher can be just about as bad as the participants. I had some people come by that I wanted to meet in my conference room, and I have some other people's work in there that I consider trash, so I wanted to get rid of it. I have back problems, and the hell with it, so I moved it out, and I wrenched my back. So, yeah, I take this stuff, too. I broke my leg in October, torsion fractured the left fibula into broken 2 places. Physician wanted to put a pin in, steel plate the pin in it. I said, no, create more complications than what it's worth. And the reason is I have systemic lupus. So anytime I get an inflammatory response, I get scar tissue form. So my organ function is like 70% near all this by itself. So all my nerves coming out of my vertebral column are tethered with connective tissue and stuff. So anyway, it got worse. So yeah. But anyway, to back up to the bone story, doctor said, okay, you got to be on calcium, vitamin D to increase, that. And so, okay. And then my collaborator started feeding me these results in December on the stuff. And he's going, they can take it. Let me have some. So I started taking it. And the doctor said it would take you 12 to 16 months before I asked for walking cast. 12 to 16 months before you'd be healed out of walking cast. They took the cast off in January, and it's perfectly healed. Wow. Good stuff. So I believe in what I'm doing, to the point that I'm getting your head. Okay, yes.
So you're competing with the stem cell for, we have anyone of influence or power who's listened to counter that so that your information can get up?
I am publishing. We are presented at national meetings. I was a keynote speaker in India 2 years ago for the adult stem cell conference there, for the International Stem Cell Conference. I'm going to be speaking at the the experimental biology meetings in New Orleans later. It's in April yet. Then they'll be doing it on the 19th of April in front of however many people want to show up, talking about the adult stem cells and what we can do with them. So it's kind of a grassroots approach. I'd say.
But Obama's put most of his money towards embryonic stem cell and the Abbas mission out there. Is that he doesn't know about it?
Well, it's not so much he doesn't know about it. He did mine to NIH, okay? I sit on, which is really crazy, I sit on NIH study sections, stem cell study sections, but I don't get any money. And the reason is there's 18 embryonic stem cell labs and maybe 2 adult stem cell labs, okay? All the money goes to embryonic stem cell labs because we're outvoting. It's all that stuff. It's just the way it is. But if enough people get treated, grassroots, we can go for the adults. And now there's people in the adult stem cell field that believe in the Mercedes-Benz approach, and there's people that believe in the Walmart approach. I believe in the Walmart approach. Get it as cheap as possible, treat as many people as possible. Mercedes-Benz approach is treat few people, jack the price up. Yeah, so that's another thing.
Ethics. I guess part I really don't understand is, I don't know if this has to do with ethics or whatever, but why your colleagues that have listened to you, make your presentation, and those that are, even if they're in the field of, or in the area of embryonic stem cell research, why they're not supporting this more? I mean, if they really are, interested in seeing, really positive outcomes, I mean, why aren't they doing that?
Because their labs would be to embryonic stem cells, not to adult stem cells. So they would have to completely retool. And most of the labs run on soft money. They don't run on hard money. I was paid by Mercer 21 years ago to teach. Research is just a sidewalk. I just happen to like to do research. But my main job is to teach. So I'd get paid by hard money. So it doesn't matter whether I get a grant or not. A lot of the embryonic stem cell labs, Harvard, Stanford, Duke, whatever, everybody runs on soft money. You don't get a grant, you're out. Whole field, herd mentality, embryonic stem cells. My first pink sheet that I ever got back from NIH, I have framed in my office. It says, lunatic frame, Johnny. Because I had cloned cells before they'd published on the embryonic stem cells, and I cloned in the mid-90s these cells that I presented. Embryonic stem cells were published until 1999. We published our first cloning paper in 2001, thinking, oh, maybe that guy's not the crap pie we thought he was. Last year, that cloning paper, the mesodermal cloning paper, got 600 hits. The ELSC cloning paper got maybe 5 hits, and we didn't get any hits on the blastomeric stem cell paper. They're just not far enough along. Lady in the back.
Since there seems to be such a big debate and controversy over embryonic, and whether it be ethical or just with the research that you were talking about, do you think that in the long run, with so much being devoted toward embryonic, it will give some more validity to what you're doing, and somehow residually it'll...
Oh yeah, right. Most definitely. Now, I'm not against I'm against embryonic stem cell research as it applies to healing adults. But I'm not against embryonic stem cell research when it talks about healing embryos and fetuses in the womb. I teach embryology. There are a lot of congenital diseases that could be healed if we knew what was going on. But before now, we weren't even allowed to work on human tissues. We work on animal tissues. And if anybody is as old as I am, remembers the thalidomide debacle of a long time ago, where FDA said no thalidomide in the United States, and said, okay, it's an anti-nausea drug. Kids came out with little flippers and no hands at all. No hands, no limbs. So the only thing that we could work on at the time, I was a little bit young for that, was rats and rabbits and mice and things like that. And they found out that rabbits are the ones they tested on, and rabbits it worked perfectly fine, no problem. But when they did it on humans, there was the problem. If we had embryonic stem cells at the time and tested thalidomide on embryonic stem cell, they would have found that out. So yes, they need the cells, but they need the cells for people that aren't born yet. For the people that are born and are out there running around, adult stem cells work perfectly fine.
So do you think policy should dictate that, or it doesn't need to be clarified more? Because it seems like we're about to people want to run the gamut of every sort of type of research now that President Obama has kind of opened it up. Should there be stricter policies or guidelines?
That's not for me to answer. That's for y'all to figure out. I'm not a jurist. I'm a scientist. So I will do my thing, and hopefully y'all do your thing.
That's our job.
That's our job.
That's your job. Find out. The one thing that's coming out right now, which I joined the adult stem cell group that we're a little hostile about, is the embryonic stem cell people say that because they're under FDA regulations to prove it to the nth degree that it's okay to use in humans, the adult stem cell people should be held under the same guidelines. That, to me, is horse hockey. So I'm sorry. I mean, we've done bone marrow transplants for 30 years. They do IV in vitro fertilization. They're not held under FDA guidelines because they set their own guidelines of what can and cannot be done. We can set our own guidelines for adult stem cells, you know. But embryonics, I would like to see a little bit more regulation, federal regulation with respect to embryonics, because I don't want to see people walking with, trunks sticking out of their heads or, whatever. And people right now are paying $50,000 to go to Thailand to get injected with a mixture of who knows what to try to get cured. Or they go for cord blood cells. Well, it depends on how the cord blood is processed is what you're going to get. Most of the time they freeze in liquid nitrogen, which gets some hematopoietic stem cells, which is okay if you want hematopoietic disorders, but if you want to cure diabetes, it isn't going to do squat.
Well, I said that cord blood.
What do you mean?
Is it worth saving?
It depends, yes. Well, it depends on how it's processed. If you squeeze the cord blood out and freeze it in liquid nitrogen, that's fine. It'll save your child or some other child that's close to match somewhere down the road for hematopoietic diseases. If then you take the cord and freeze it at minus 80 degrees, you'll preserve the stem cells. They can be used then for other, for adults. So it just depends on how they're processed. Right now, they're processing it like they would for blood, which is freezing. aTPSCs, one of my other presentations, American Type Tissue Culture Collection has a book about this thick on how to culture basically differentiated cells and progenitor cells. Okay, and I say it very good for my presentation. And it works for germinal lineage cells. They've read the book. They know what contact inhibition means. They follow the procedures. BLSCs and ELSCs, on the other hand, didn't read the book. They don't understand what contact inhibition means. They form multiple layers and this sort of thing. So it's just a little cutesy there. When I go through on the more scientific side, I gave you a more general talk this time. Yes.
Okay, and he said when it squeeze the blood and you save the cord blood. What kind of diseases do you say that we up?
That would be hematopoietic diseases like lymphomas, any bone marrow-based diseases. Leukemias, yes, most definitely.
I recently had a baby and no one could really tell me if it was worth it or not. It was kind of like...
Okay, it depends. And it depends on which company you go with. Some companies will charge you $5,000 for the initial thing, and then will charge you $1,000 a month to store. Hey, money makers, capitalism, what can I say, But the way they store it is in the liquid nitrogen. So the only way it would be that would help your child would be for a hematopoietic disease. Right now, well, hopefully within 2 years, we're hooking up with a company that freeze-dries stems. So we're hoping to freeze-dry stem cells. So there'd be a one-time charge, freeze-drying, and we give you the cells, and you can keep them on the counter in your kitchen. And whenever you need, we take them, reconstitute them, and use them. Freeze-drying, the process is it wants to freeze in a normal cell, if you remember that big one, there's a lot of water in that cell. When ice freezes, it forms spines, breaks the cell membrane. Our cells are so small, there's very little water, so it can freeze dry. Theoretically, we don't know yet. Theoretically, it could freeze dry without a problem. And then we could reconstitute and go for it.
Is that why you can freeze in a negative 80 degrees Celsius too? Like
Yes, exactly. Exactly. We don't get the crystallization. That's why, and we slow freeze. We drop 1 degree per minute rather than flash freeze of induction, which you need for larger cells, progenitor cells, and differentiable cells.
If this research, I mean, if it does catch on and get to the point where adult stem cells are accepted, what do you see the future for this? I mean, are there going to be things such as stem cell banks for individuals? Well, what do you see?
I foresee biobanking. Like I said, we can biobank your cells if you need them for the future. Unfortunately, in the Afro-American population, not too many people want to either donate organs or even donate blood. We could biobank. We have this compound which just increases the number of stem cells like it's going out of style in the blood. So from I'm a unique individual. I have close to 800 million cells running through my per mil of blood in my system because I had the lupus. But our normal one has 168 million, but even double that, that's 311 million. And you freeze them down in 1 billion cell aliquots. And that's, 311 aliquots that you could use for someone else. And then you could expand to whatever population you needed to transplant. So yeah, I could see a lot of uses. I mean, we're going after every single disease we could pick up that is not genetic. My disease is genetic. I need an allogeneic transplant. And I went to FDA about that. And they said, no, they'd do that until you can prove that autologous stem cells work. Once I can prove that, then I can go get myself an allogeneic transplant so I can cure myself.
Very interested in all of this.
Yes, ma'am.
Okay. On the news, they had a man that was a paraplegic. He had been in an accident. He was excited about, their prophecies that were coming out, reversing, and all of that. I don't understand that. Would adult stem cell work for him, or would it have to be embryonic?
Adult stem cell would work with him. It would work exactly the same way as embryonic stem cell would work, without the problems of cancer formation and allogenicity. Yeah,
That's what you were saying. So if that be the case, then I just don't understand why more people won't go ahead and push it. It's just lack of knowledge.
lack of knowledge, lack of understanding. That's why I'm here tonight, donating my time, Michael, to get more people informed about adult stem cells.
So this is a really, what's a dumb question, but I have to ask this, okay? So I understand.
Glad it.
In the little pewter bowl or whatever it is, petri dish, and give him petri dish with them. Okay. So then when you first have it, it's embryonic. When does it become adult? I mean, is it at a certain number of days? I don't understand. I'm like, well, how do you?
The embryonic stem cells in it. Once it's put into a petri dish, it's always an embryonic stem cell. You have to differentiate it down to an adult stem cell type, but at that point it becomes an adult. When it becomes a progenitor cell, when it's committed to a lineage, it becomes an adult cell. At which point it's lost its plasticity. It has a biological clock of 50 to 70 population doublings, and it will senesce and die. And we've done that to our cells, and the embryonic people have done it to their cells as well.
So if you talk about biobanking, at what stage would be the best kind to biobank, or, say you're
DLSCs, the most perfect was. Because one of the girls who worked in my laboratory, she worked in my lab for 11 years, actually. I had her when she was 4 years as an undergraduate in Mercer, like I told you, pull them off the streets. 4 years as a medical student. Then I had her 3 years as a resident. And her idea was for people like yourself, say if you had ovarian cancer, okay, and you had to take chemotherapies, you say, over my phone might be. Ruby says. Okay. If you have the chemotherapy, like in the standard one, say for ovarian cancer, you use sulfan. You'd wipe out your bone marrow and it'd wipe out your gains. Okay, MAC. Coming back out of it, get up, identical twin, a line-yard business here, and get your or potentially use your day's cord blood to constitute yourself. Now, the question is, if you want any more children, you want to adopt? Do you want a sperm? Do you want a surrogate mother for your husband's sperm? Or so on and so forth. Or do you want your own biological kids? Tina's project was we were going to do it in mice, and our mouse pushing it passed away, unfortunately, so we're going to do it with pigs instead. We're going to treat the pigs with busulfan and knock out their bone marrow, knock out the gametes. And we're going to reconstitute the bone marrow, and we're going to inject BLSCs into their gonads, specifically females, to try to reconstitute ova. Then we're going to mash that with a normal male, and if we get progeny, you can have your own biological kids. That's why I would take a BLSC over an ELSC. And the other thing I want to do is I want to create hunter killer cells. And there's a cell that occurs in your placenta called a Hofbauer cell. And I drill this into my medical students umpteen times. That cell is the Arnold Schwarzenegger of the macrophage set, Terminator 3, and it'll take out anything. And I saw a demonstration, and it had a 100-millimeter petri dish. And the bug, quote unquote, that forms syphilis is looks like coiled spring. It's about an inch long. You put it on one side of the dish, they put a Hofbauer cell on the other side of the dish, closed it up, and a Hofbauer cell you couldn't see with your naked eye, put it in the incubator, came back the next day, Spire T was deader than a doornail, and the Hofbauer cell says, come on, bring it on, give me another one, give me another one. I want to make those cells mobile. Okay? And there's other people that we work with that have artificial chromosome technology. So instead of, you have viruses that you knock genes in with, unfortunately, they knock genes out too. With an artificial chromosome, you can add any cassette gene that you want on it, put it in the cell so you'd have 47 instead of 46, but it would replicate normally. The idea is to put a cassette in there that says, okay, you go after this gene sequence. You put it in this hunter killer cell, you inject it in the body. It can go after Ebola, smallpox, polio, any one of the nasty viruses. That's something I'm working on this side.
That's also Schwarzenegger cell was in the placenta.
Yeah, it's called a Hofbauer cell.
So
It protects the embryo fetus from week 3 to week 20. If it's intact, nothing that's alive will cross that placenta and make it to the embryo fetus. It's deader than a doornail.
So you can only retract that cell from placentas.
No.
Wait, or
The placenta is derived from the trophoblast, which is derived from a BLSC. So if I can co-culture the BLSCs with the Hofbauer cells, I can make Hofbauer cells. Yes.
You had mentioned earlier that Japan is leading in the stem cell research arena right now. Is that
Pretty much embryonic stem cell.
embryonic? How important is it for our country and for the United States to maintain or surpass them and get the
Upper hand?
upper hand?
Again, that's not a question. That's not, I would go for adult stem cells per se, not embryonics. So
Or is anybody else in the world using adult stem cells? No. Nobody.
I'm the only one in the world with totipotent stem cells, and I'm only one of 3 labs in the world, all in the United States, who pluripotent stem cells. There's Tony Adelet at Wake Forest with embryonic stem cells, and Maurice Radachak at University of Kentucky with a very small embryonic-like stem cell. We're the only 3 with pluripotents. We're all U.S.-based. So I would go with adult stem cells first, go with embryonics second. Embryonics, yes, embryonics are important, again, to treat the fetus and the embryo. But there are more adults running around in this world than there are fetus and embryos right now that can be cured if we just had the technology and the finances to do it. And you think of people that that might be Parkinson's, might be Alzheimer's, might be dementia, diabetes, COPD, and the list goes on and on and on. Yes.
I mean, it sounds like, it's just endless and wonderful, but do you have a primary focus at this point? Like, what is the next step for you? Like, when you talk about Alzheimer's or Parkinson's, one in particular that you're really focusing on?
Okay, the one I promised, there's a group out there called Stem Cell Pioneers. And they're the ones that go out to these places and get stuck for 50 to 100 to whatever thousands of dollars trying to find a stem cell technique that works. Most of these people are COPDs, chronic obstructive pulmonary, whatever it is, COPD disease. I promised them that I would go after COPD. So that's the focus of my first grant for the NIH Stimulus Awards. My first focus for a non-stimulus and non-NIH grant is the Michael J. Fox Parkinson's Foundation, because we have Parkinson's data that our stem cells work in animals. So they should work in Parkinson's, in humans.
Yes, I know some universities, major universities that had like pharmaceutical companies that have sponsored labs that have invested a lot of money into research. That's true. Have you looked to have anybody like that or any organization like that sponsor your research?
I believe in the Walmart approach. Okay? And the Walmart approach says you bring it to the people as cheaply as possible. If I had a big pharmacia company, they're not going to go for as cheap as possible. So that's my own thing. So I work with a foundation. It's called Dragonfly. Wherever the name comes from, who knows. They will fund my research. It's basically they'll match funds. Whatever funds they get in, they will match to fund my research. So that's where some of my money comes from. I donate part of my salary every month to Mercer University to pay for my research. When my father passed away, there were 3 kids, my mom, he divided his estate into 5 parts. One for each of the 3 kids, one for my mom, and one for my research. When my mom passed away, she divided her estate into 4 parts. One for each of the kids and one for my research. So I work off my parents' estate trust as well. Self. And I try NIH and they think I'm lunatic for him, so I need one case. Because basically I'm so far ahead of everybody else. You can't believe it's real. We karyotyped in the hell. I don't know. We've gone through all the hoops they wanted us to go through to prove that the cells are real, and they still don't believe it. So there's not much I can do about it, except prove it in humans that it is real.
Any other questions? Well, thank you very much, Dr. Be careful.
Thank you for listening to me.